Hi, my name is Bryce Summers, and today we're gonna compute the determinant of a matrix using cofactor expansions. So here, as you can see, we have a 3 by 3 matrix that we'd like to compute the determinant of. We would have entered it after creating it using the new matrix screen. So the first thing we do whenever we're doing a cofactor expansion is we look through the rows and we look through the different columns for any places where there's lots of zeros. Zeros allow us to make it very simple for us to solve the problem once we've done the expansion, because the zeros cancel out the minors of the matrix. So here we see the column 1 has 2 zeros. So what we're going to do is we're going to compute the cofactor expansion by column 1, which means that we're going to compute the three minors and the associated scalars of this matrix with regards to column number 1. So first of all, since this is a determinant problem, we want to go into determinant mode. To do that, we click on the determinant mode button. Once the determinant mode button has been clicked and we go into determinant mode, the matrix will show bars that represent that we're taking the determinant of the matrix instead of the normal squared angle bars. This is merely for aesthetics. There's no bearing, but it also helps us to remember that that's our goal. The other thing about determinant mode is it gives us a scalar on the side, which will be very useful in our computations for making them easier. The scalar represents a number by which the entire matrix should be scaled by. Since this is the beginning, it's represented by the multiplicative identity, which is 1. So therefore, the scalar really does nothing. It just keeps the matrix itself. So we're gonna expand by column number 1. So first you click the column or row you want to expand by, and then to do the cofactor expansion, we click on the cofactor button. Once this is done, it's computed all of the minors in the matrix. In this case, the minor is 0, 1. The 0 stands for row 0, column 1. Then you've got 1, 1, which is row 1, column 1. And you've got the minor 2, 1, which means row 2, column 1. If you notice the minor, if you notice the first minor 0, 1, it is been computed by the scalar is 0 times the minor, which is -5, -4, -2, and 2. It's also been multiplied by either -1 or 1, depending on the following rule. You decide whether to multiply a given minor by -1 or 1, depending on which location in the original matrix is. The positive ones, negative ones form a checkerboard pattern. So if the scalar comes from the first box, it's a positive one. One next to it negative. One next to it is positive. So see, you begin at positive, and then this is negative. Positive, negative. Positive, negative. Positive. This is still 0 because 0 multiplied by anything would still be 0, so we don't see it. For the second minor, the minor is equal to 2, which comes from here, 1, 1, see, 1, 1. Multiply the minor, -1, 2, -1, 2, -2, -2, -2, -2. And then this 2 has been multiplied by +1 because it's in a positive area of the checkerboard square. See, positive, negative, positive. For the final minor we've created from -1, -2, -1, -2, and then -5, -4. -5, -4. The zero scalar comes from row 2, column 1. Row 2, see, column 1, which is a 0. And then it gets multiplied by negative because of a -1 because of the checkerboard rule. Positive, negative, positive, negative. So the cofactor expansion says that the determinant of the original matrix is equal to the addition of the determinant of each of the matrices multiplied by the scalar. So in this case, no matter what the scalar of the minor 0, 1 is, it will be multiplied by 0, and so it will end up being 0. So we can disregard it. That's why we like the 0 so much. The same can be said for the minor of row 2, column 1. So now we've reduced the determinant to being the determinant of this small 2 by 2 matrix multiplied by 2. For this we can use the rule for 2 by 2 matrices, whereby we multiply the two numbers of the left diagonal, -1 times 2, subtracted by the numbers of the other diagonal, -2, -2. And then because of the cofactor expansion, we need to multiply by the scalar. So we click here to add it, and then we'll be multiplying this determinant rule computation by 2. So once we're done, we press the evaluate button, or E. And therefore we've computed the result of -12. And that's that. This has been how we've now computed the determinant of this 3 by 3 matrix, which ends up being -12. Thank you for listening. Goodbye.